As we continue our unit on modeling data, today we're going to focus on relative frequency. We're going to continue looking at two-way frequency tables, and we'll learn how to interpret and write conditional statements using those relative frequency tables. So you can follow along in your notes. We've got the relative frequency task that we're taking a look at today, dealing with that from one we looked at the very beginning of our unit, where Rachel is thinking about the data she and her mom collected for the average number of texts a person sends each day. And she started thinking that perhaps a two-way table of the data they collected would help convince her mom that she does not send an excessive amount of text for a teenager. The table separates each data point by age, teenager and adult, and by the average number of texts sent, more than 100 per day or less than 100 per day. So if you remember last time in our first lesson, we looked at a histogram and a box and whisker plot that compared all of the data together, and we looked at it also with just the teenager data. So if we look at the two-way table, it helps us compare the information a little bit better. So I just first of all want you to just come up with two observations that you have once the data is listed in this two-way table. So write something now that you observe, two things that you notice based on the information in the table, and then when you're ready to restart the video, you can see what I put down. So pause it now. So this is what I noticed as I look at the teenager totals. I noticed that the majority of teenagers send more than 100 texts per day. And looking at just adults, the majority of adults send less than 100 texts per day. So that's what we can observe based off just looking at the table. We can observe maybe that there are equal number of teenagers and adults. Maybe that overall there are more that spent or sent less than 100 texts per day. Maybe you had some other observations. To further provide evidence, Rachel decides to do some research. She found that only 43% of people with phones send over 100 texts per day. She was disappointed that the data did not support her case and confused because it did not seem to match what she found in her survey. What questions do these statistics raise for you? What data should Rachel look for to support her case? So think about that and answer that one. And then after looking more closely at the data, she found that other percentages within the same data that seem more accurate with the data she collected from her teenage friends. How might Rachel use the data in the two-way table to find percentages that will be useful for her case? So think about those two questions and write something down. And when you're ready, restart and see what I put. So pause it now. So these were my thoughts. I thought after looking at the data, and she found that only 43% of people with phones send over 100 texts per day. We would try to find out, well, how many people were surveyed? And was this a small or large survey? Are we looking at this particular survey right here? If so, it's not a very large number to work with. I would try to get a bigger number of, a larger number of participants in the survey. Also, what were the ages of those surveyed? Is this a total? Is the 43% total? Is it just teens, just adults? So those are some questions we would look to have answers for in order to have a better answer for, should I send more text or not? And then how could she use her two-way table? Well, she could calculate the percentage of teens who send more than 100 texts per day. If we can see the percentage, it helps compare the data a lot better. Or calculate the percentage of people who send less than 100 texts that are also teens. So find out of the people who send less than 100, what percentage are teens and what are adults. So if we can get those percentages, it'd be easier to compare the data. So in part 2, it says once Rachel realized there are lots of ways to look at the sets of data in the two-way table, she was self-motivated to learn about relative frequency tables and conditional frequencies. When the data is written as a percent, this is called a relative frequency table. In this situation, the inner values representing a percent are called conditional frequencies. The conditional values in a relative frequency can be calculated as percentages of one of the following. So either percent of the whole table, or percent of the rows, or percent of the columns, the relative frequency of each of those. So she wants to emphasize that a person's age makes a difference. So she wants to focus on the row of values since teens and adults are listed in the rows. And then she can write conditional statements about the number of texts persons like to send based on their age. This would be the relative frequency of row table. So let's fill in that percentage of teenagers based on the conditional frequencies of the highlighted rows. So if we take a look at that, let's look at the teenagers. Well, if there's 20 out of 24, Do the calculations, that's about 83% who send more than 100 per day. And 4 out of 24 is 17% who send less than 100 per day. The adults, 2 out of 24, that's 8%. 22 out of 24 is 92%. And then we can see the overall. 22 out of 48 is 46%, and 26 out of 48 is 54%. So since the percentages focus on row values, all conditional observations are specific to the information in the row. So of all the teenagers in the survey, let's see, 83% average more than 100 texts per day. That's one conditional statement we can make. Why don't you write another conditional statement based on the relative frequency of row? Pause it now. So one of the conditional statements I wrote, I compared the adult row, and I said of all adults in the survey, 92% of those adults send on average less than 100 texts per day. So we can compare information in the rows and make a conditional statement based off of the information that we have. Here we have a relative frequency column using the same data. This time all the percentages are calculated using the data column. So of the people who send more than 100 texts per day, what percentage are teenagers and adults? So write two conditional statements based off of the column percentages. So pause the video now. So when we compare that data based off of how many texts are sent, of all who send more than 100 texts per day, 91% of those are teens. And of all who send less than 100 texts per day, 85% of those are adults. So it becomes pretty evident that the teenagers are sending more than 100 texts per day, and that's very common. And it's very common for the adults to be less than 100 texts per day. Now let's take the relative frequency of the whole table, and now we're just creating percentages of the whole. So teenagers who send more than 100, what percent is that out of the total? Same with teenagers who send less than 100 out of the total. Each of these are taken out of the total. So write two conditional statements for those and answer this question: how do relative frequency tables impact the way you look at data in two-way tables? So pause the video now and restart it when you're ready to see my answers. All right, so as we take a look at the relative frequency of the whole table, we notice that 50% of teens and 50% of adults were in the survey. And another thing that I noticed was 54% of the people send less than 100 texts per day. So those are just different things that I noticed. Maybe you noticed some other things as well. So the final question: how do relative frequency tables impact the way you look at data in two-way tables? Well, some of the things that I noticed is that I tend to look closer at the conditional frequencies, at the relative frequencies of each row or each column, to try to gather more information based off of who's answering what in a survey, or which particular group prefers what, as opposed to just the overall percentages. And you can glean more information based off of what each particular group is doing and understand it a little bit better. So you worked with calculating those relative frequencies and learning how to use and interpret those two-way tables and write conditional statements based off of those. Your assignment is then to work on some review on linear functions. That would be our wonderful friend y equals mx plus b, slope-intercept form of a linear equation. So hopefully you remember that. And then going back to some relative frequency tables, providing observations and creating the data with that. And then going into one variable statistical measures, which we did at the beginning of this unit: mean, median, mode, range, and creating box and whisker plot or a histogram, and then comparing that data. So that's all the time we have. If you have questions, I can help you out with that in class.